Okay, welcome to Unit 6, Properties of Parallelograms. Let's take a look at this. This is 6.2 in your textbook. Okay. Properties of parallelograms. Let's look at this word right here, parallel. What does it mean to be parallel? Parallel are lines that do not intersect and they have the same slope. So if it's called a parallelogram, we can expect to have two sets of parallel sides. So these sides are parallel and these sides are parallel. So we're going to learn about properties of parallelograms. Okay, before we go into properties of parallelograms, I'm going to have a quick review of Venn diagrams. Venn diagrams is a way of organizing material. We use it in chapter 2 with the hypothesis and the conclusion, and we always said that we start with our hypothesis, which would be right here, the rose, and we work from the inside out. So, if it is a rose, then it is a flower. Is that a true statement? Yes, it is. Well, let's go the other way. If it's a flower, then is it a rose? No. Why? Because you can give me a counterexample and tell me a flower that is not a rose. So keep that in mind as we go forward. Okay, here's the Venn diagram sheet from your handout on parallelograms. When we take a look at this, let's just concentrate here on parallelograms. We can see that the squares fall in parallelograms. So we will be able to say if a figure is a square, then it is a parallelogram, and it will be true. You always want to reference back to your Venn diagram to make sense of the problems that are asked on page 242 in your handout. Okay? Will we be able to say if it is a kite, then it is a trapezoid? No, because those two have nothing in common. When Venn diagrams do not overlap, they have nothing in common. Okay, one of the properties that you must memorize with one of the properties of a parallelogram is that opposite sides are congruent. And we always make sure we mark it. Opposite side. Clearly by the markings and by the properties of a parallelogram, you can see that AB is congruent to BC. Is there anything else we can conclude? Yes, AB is congruent to BC. Why? Because one of the property of a parallelogram is that opposite sides are congruent. Next property we're going to focus on is opposite angles are congruent. Opposite angles are congruent. All right, so this angle right here is opposite this angle here. Let's label our figure parallelogram ABCD. We would expect angle D to be congruent to angle B. Now, how will we mark angle A congruent to angle C? We can't use the same notation because we don't know if they're congruent to the consecutive angle, but we do know they're congruent to each other. Second important property, opposite angles are congruent. The next property, the third one, is diagonals bisect each other. What does that word bisect mean? Split into equal parts. So, let's make a diagonal here. We have a diagonal here that's called GE. And the other diagonal here is called DF. And if they bisect each other, then they split each other into congruent parts. So, I'm going to label this point right here, the point of intersection, I'm going to call it point P. So now you can clearly see that segment GP is congruent to segment PE because the property states that diagonals bisect each other. Anything else we can conclude in this picture? Exactly. Segment DP is congruent to segment EF. We are moving right along. Okay, we have one more property. It says consecutive angles are supplementary. Okay, if we break this down, what do we know in these words? We know that supplementary is 180. We know what angles are. They're degree measures on the inside. But what is this word consecutive? Sounds like we dealt with that word back in Unit 2. Next to. So, what is next to angle P? What is right next to angle P? Well, angle X is next to angle P. So we're going to say that angle P is 60 degrees. So this states that if consecutive angles, which are angles right next to each other, should be supplementary. So if I tell you that angle P is 60 degrees, what we expect angle S to be? You got it, 120 degrees. Well, angle S here is right next to angle R. So what we expect angle R to be? Again, 60 degrees. Well, angle R is next to angle Q. So what we expect angle Q to be? Supplementary to 60, that would be 120. Okay, what you're going to be responsible for knowing with the properties of a parallelogram is opposite angles are congruent. You have to know that. Opposite sides are congruent. The diagonals bisect each other. And consecutive angles are supplementary. Once we know these properties, we will definitely be able to problem solve. I will be able to give you problems like this and tell you that this side is 6 and ask you what this side is. Or you would say, first thing you ask yourself is this. Am I dealing with an angle, a diagonal, or a side? That's the first thing you want to do. Well, this is a side, and so what do my properties say about the sides of a parallelogram? Well, let me see. Who talks about a side? Oh, here it is. Opposite sides are congruent, therefore X is equal to 6. Okay, here's our first application problem. Every time we see a problem, the first thing we do is we read the directions, and the direction says find the measure of all angles. Anytime we deal with measure, we know that our answer is going to be in degrees. Okay? Well, if we're dealing with degrees, we ask ourselves, are we dealing with angles, diagonals, or sides? Which one? Yes, angles, because the direction says angles. So we want to know, what do our properties say about angles? What do they say about angles? Oh, opposite angles are congruent. So what angle is opposite angle B? You guessed it, angle D. So angle B is congruent to angle D. That's one of the properties. And the next thing we want to do is substitution. So we're going to substitute in for angle B, 28 plus 30 equals 17A plus 48. All right, once we set it up and we do our subtracting and our adding, we find out A is 6. And so we're done, is that right? Oh, no, we're not. We think about our problem-solving skills. What is the question asking? It's asking us to find all the measures. Have we done that? No, we haven't. So now we need to go and plug it in. So we're going to start over here with the measure of angle A. The measure of angle A is equal to, this will be 5 times 6. And 5 times 6 is 30, so that angle is 30 degrees. Okay, so I'm going to replace angle A with 30 degrees. Is there anything I can conclude? Now that I know angle A is 30 degrees, you guessed it, looking over here, the measure of angle C is also 30 degrees. Again, so if angle A is 30 degrees, how much is angle C? 30 degrees. So opposite angles are congruent. Okay, so we still have to find angles B and angles D. So right now, let's look at angle B. It is 28 plus 30. We're going to come over here. 28 plus 30. We found out that A was equal to 6, so we're going to do substitution. 20 times 6 plus 30. And so if we multiply this out, how much is 20 times 6? Is 120 plus 30 for a total of 150 degrees. So therefore, angle B is 150 degrees. So angle B is 150 degrees. So what else can we conclude? If angle B is 150 degrees, we can conclude that angle D is 150 degrees. Okay, this is the last example, and what I want you to do is make sure you read the directions very carefully. I would like for you to solve this, and I would like for you to turn it in to the teacher next class, proper notation, and answer the question. And you can get 5 extra points on the quiz, but they all must be correct. Good luck. I have to add one more piece of information that I left off. There you are. Now, good luck.